All right, we're on lesson 23.3. So you need some scratch paper and some graph paper. Write these functions down. You'll notice these functions are inverse functions because one is an exponent base 2 and one is a log of base 2. To graph these, you want to make an input-output table. So maybe pause the video and create your table. Once you have your table, you can plot your points. All right, let's talk about making the table for log base 2 of x. The easiest way to make a table, if I already have a table of the inverse, is what? Flip it. The easiest way to make a table for logs is to do the inverse and flip it for most people, because logs are harder to think about. It takes us a little more time to make an input and an output. Because if I were to do this, do you see a problem with putting a -2 there? The base and the argument have to be positive. So that's not even a value I can do. So it's kind of confusing with logs because we're less familiar with them. However, you could come up with values. For example, 4. If 4 was right here, that's saying, what do I have to raise 2 to get 4? And the answer is 2. If the x value was 2, what do I have to raise 2 to get 2? I'd have to raise it to the first power. So you can think through it, especially if you're doing this from scratch and you don't have the previous table. But sometimes it's just as quick to make the table and flip it. What would happen when I put these functions on the same graph?
Opposites.
True. They would reflect over y equals x. I don't need you to do that. I just wanted to show you. Maybe you want to make a note if you forgot that. But if they're graphed on the same graph, you can see they will reflect over the line y equals x. Any questions on making the graph? All right, we're going to do several questions regarding these. Let's start with x and y intercept. I'll give you some time to think through that. X and y intercepts for both. Thomas, what do you think for the x-intercept of this first graph? Right. This is the x-axis, and it never touches it. So we write none. Don't write 0, like that there are 0 of them, because that makes it sound like it's going to hit at 0. Thomas, what do you think for y-intercept?
1.
1. You can put 1. I would take that, but it is the point over 0 up 1. Lydia, what do you think about x-intercepts for the second graph?
1, 0.
Yep, it is the point over 1 up 0. Lydia, what about y-intercept? None. Never touches. Notice the relationship between the x-intercept of 1, the y-intercept of the other. These are the same, and these are sort of both 1, but the points are slightly different. Okay, next is domain and range for each. I'm gonna erase mine so I can see it all at once, but you were just gonna keep on going
Are
down
we
the
doing
paper.
like interval or?
Any you want, interval, set, or inequality.
Thank you.
I prefer interval notation. Keegan, what method did you do? Form.
For like, I did different ones.
Oh, that's fine. What do you have for the domain for the first graph?
I had like that 2 points.
Okay, what are they?
Negative infinity, comma infinity.
Yep. So this is called interval notation, the smallest number, in this case, negative infinity, to the highest because it goes forever this way and it goes forever this way. It just gets very high. What do you have for the range for this graph?
0 is less than y.
Okay. That'll work. If you want to do interval, it would be 0 is the lowest number, but not included, to infinity. You could actually put just that would work too, but yep, good. I'm going to leave mine like this so they're all the same. Domain over here, it doesn't go to negative infinity, it stops. You can only put in 0 because look, your x's, you can't have negatives there. You can't even put 0 there. So that's why we don't include 0. It goes to infinity. The range, it goes down to infinity. Is this going up to infinity? Yes, going very, very slowly. So negative infinity to infinity. Check out the relationship here. This domain is this range. This range is this domain. That will always happen for inverse functions. Let's do, look it up. End behavior, we call it. And I want it to be what we call arrow notation. End behavior, arrow notation.
Sorry, man, I'm coming. I got.
All right, let's check the end behavior. For the first graph, as x goes to negative infinity, my y value is approaching 0. As I go to positive infinity, the y's are going up forever. Infinity. Over here, you kind of have to change something because look what it says. It says as x approaches negative infinity, which doesn't actually happen. X approaches 0. Change that if you have it wrong. It's not allowed to approach negative anything. So it can only get to 0, but not touch it. And as it gets close to 0, you're approaching negative infinity. As I go to infinity, I go to positive infinity. Notice the relationship here. It doesn't kind of crisscross. This matches up with that one, and this one is sort of flipped. Something's flipped, kind of like they did before. I believe the last thing is asymptotes. ASY. MP totes. I think we've only talked about what we call horizontal asymptotes. So we look at the end behavior. If it's approaching infinity, that doesn't count. This one is approaching 0. So this is an asymptote, something that's approaching at its end. And so we would call that a line with a height of 0. This one, at its end, it approaches negative infinity and positive infinity. So it has no horizontal asymptotes. But we will introduce maybe, for the first time, I'm not sure, vertical asymptotes, a line that it approaches vertically, which is we are vertically approaching the x direction. We're approaching the line x equals 0. So copy that down. In the x direction, we're approaching the line 0, vertical asymptotes. We'll do a lot more with vertical asymptotes and horizontal asymptotes in April, May. There's something called slant asymptotes. I'll be honest, I can't remember how to do those because I haven't done them in 13 years. But that's a pre-calc topic. So we don't have to do those. I should look them up because now that I say I forget, I kind of want to remember how to do them. All right, my plan originally was to do 2 examples. So our next example was going to be something like this. For more practice, we are going to take a vote on whether you would like more practice or you think we're good because it's kind of the same thing. Close your eyes. If your eyes are open, then we're going to do more practice. Raise your hand quietly if you think it'd be a good idea to do another set like this. Put your hands down. Open your eyes. There was like a sort of maybe-ish, I'm not sure hand. So since it wasn't a definite, yeah, we need more practice, I'm just going to talk through it briefly. Are these inverse functions?
Yeah.
Yes, they have the same base, exponent and log. Is this an inverse function of this? No, just because it has the same number, that's not the way it works. One's got to be a log, one's got to be an exponent. If I graph them, would they look similar to this? Yeah, but I would have an input of, if I input 1, I'd get 5. Input 2, I get 25. 1/5, 1/25. So very similar. And many of your relationships would work out the same. Many of your answers would be exactly the same. I believe your x and y intercepts would remain the same. Your behaviors would remain the same. Your asymptotes would remain the same. Domain and range, if I said that, would be the same. I don't know anything that would switch. Your graphs would hit different points, but many of these things would remain the same. Turn to number 5 on page 367, please. Number 5, page 367. We are going to be doing part of this. There are 5 graphs. We're going to talk about all 5. We'll only graph a few of them. So try not to get too far ahead. Sketch the parent function. You can see what the parent function is based off the base of the log. This is a log base 2 with a 3 here that's going to change the graph in a way. This one has a +4 and a 3 and all kinds of stuff. So left, right, stretch, string, up, down. All stuff we've learned before, but we've never done it with logs. It has the same effect as with every other graph. So we need to plot this parent function. We have already plotted the parent function. So pause for just a second. Let's say it's not one we just did. Let's say the parent function was this. if we find this hard to graph without a calculator, what could I do?
Inverse it and find a table for that.
What is the inverse?
Uh,
6 to the x. If you find this difficult, we are not doing this. I'm just talking about it. If this was your parent function and it was hard for you to graph, you would graph maybe or write the points for this function. And you would flip that. That would be those would be your points. Are we comfortable with graphing logs? Okay, so we already know what this one looks like. So go ahead and plot just the parent function. I'm going to label it with a capital P for parent function. I would connect it with your arrows. It's going down forever, up forever. Be careful that it doesn't cross the y-axis. We are going to graph this one together. If this is my parent function, what are your guesses on what the 3 will do? Raise your hand. Come on. Think about transformations, left, right, up, down, stretch, shrink, reflect. Jonathan, what do you think?
Vertical. Well, isn't a vertical stretch? It's going to be a stretch by 3. Yeah, it's vertical, but it's also really wacky. It's a different direction. It's vertical. Stretch.
Final answer?
Vertical stretch by 3.
Vertical stretch by factor 3 is correct. So you are going to take every current height, y value, multiply that height by 3. That's all you have to do. Vertically stretch the height by 3.
No, I'm confused.
You got it now?
Yeah.
For this new graph, does it have the same domain and range as the last one?
Yes.
Yes. It has the same everything pretty much as the last one in terms of those main ideas we talked about. All of these will not have the same, but those graphs currently have the same domain range, x-intercept, y-intercept, all of those things. We are not going to graph B, but can somebody tell me what they think would happen to the parent function? Left 4, and we'd still do the stretch by 3, right? Very good. So we are not going to do that one, but it would take the parent function left 4, and it would vertically stretch it by 3. I would like us to plot this next one. Take your parent function, left 4, vertical stretch by a factor of 3, and then go down 2. We don't have to do anything with fractions. Because the heights are not fractions. Your heights are -1 and -2. What would be different about this graph in terms of some of those main ideas we discussed compared to the parent function? Yes.
The asymptote changed.
Yeah, the asymptote changed. We are now getting close to an x value of -4. Because look, I can put a few negatives in there. Because if I put -1 in for x, that doesn't create a problem. That creates an argument of 3. So your domain would change. Your range wouldn't change. Your asymptote would change. So some things do and some don't. Your x and y intercept changes. Your y intercept is 4. Your x intercept I wouldn't ask you for because it's probably not an exact value or whole number.
So like that one, can you flip it to be like the other way, like the exponential form, or is that just?
Oh, write the inverse.
Yeah.
So you would have to flip x and y, solve for the new y.
With the log in it?
Yeah.
What?
I'm not doing that today. Not today. We are not going to graph D, but we are going to talk about D because I find this one super interesting. Think about what this graph is going to do compared to the parent function. I like the sound effects. This one blew my mind the first time I saw a problem like this. I had somebody with a really good guess last hour. What's your guess?
Like the horizontal stretch by factor.
That is a very good guess. Other guesses?
I think it's gonna go.
I can't do it.
You can do it a math back.
Can you do this?
What?
Oh,
Oh,
I'm not sticking my finger.
I can't do it.
But
Jonathan, did you have a guess? I saw your hand up for a second. Sounds like you got to think some more. You don't have a final answer ready.
Wouldn't it just shift to the left more?
Mm-mm. Here's what happens. This is so cool. This is a single log with multiplication. What can we do with a single log with multiplication?
That is like what
I was looking for one above it.
What can we do with
you like break it apart.
break it apart? If it's multiplication, I'm going to break it apart into logs with addition. So everybody, take this single log, write it as 2 separate logs. We've done a lot of this before. It's multiplication. So now it's log base 2 of 8 plus log base 2 of x.
So you have 2 different graphs and you just
This
one bit.
is a numerical value. There are no variables here. 2 to what power gets you 8?
Oh. 3.
3. This is 3.
No.
What? That 8 moved it what?
Perfect.
Up 3. I know. I didn't see that coming either. I did, but can I
what
do
if
it?
I just like said that? And I was like, actually, that one's the graph up there.
Honestly, I was like,
Just
you're
like,
stupid. Wait. Like,
Yeah, they probably would have laughed at you.
Yeah.
And I would have been mad that you guessed it.
So funny.
This is pretty cool. So you would know how to graph this. You would take your parent function up 3. Just make sure that you have this written down in case this happens again. Because many times that multiplication there, we would do a horizontal stretch or shrink. But with logs, the way they work is it's multiplication, which is separate.
Why did I now be so picky?
Crazy. Please graph the very last one.
Oh, this is kind of easy.
-3 log base 2 of x.
There's too many lines on this spread.
I know.
I know, mine's at least color coded so I can take my blue graph.
Mine just looks, well, you also can just like hit the line and then flip it.
Well, I didn't actually flip it. I took this graph and I went 6, okay, -6, 3.
Oh,
Okay.
That's what I'm doing.
I think I got to just take a
I know I could click it and hit flip, but I
I'm
didn't.
taking, geobex and just flipping it.
Just make sure you don't flip the parent function. You could, you just have to multiply by 3.
Tortilla chip day. Why didn't we have nachos today instead of yesterday?
Because they don't pay attention to what day it is.
They should though. They're uncultured.
Well-
That would be nice. Like,
Just let you guys know.
All right, once you guys are done with this, get ready for your homework.
So which are
Do you guys know the lunch ladies' names by chance?